Hi. So in here we will be exploring the builder pattern using Golang, and here I have done something interesting. I have also in added the um, way the prototype. I've simulated the prototype how we do it in JavaScript. So how I have done it, I'll be explaining everything related to how the builder pattern works and what is builder pattern and how to do it in Golang. Uh, so before anything, let me start with showing you how the base class is. So it's a basically it's a base struct. So let's go to the builder and base, and here I have this base structure, and this base structure is has a field which is a private field, and I have this as an internal um, field, and if builder if it is if it is using the builder or not, if it's a boolean. So this will tell that ensure that this current base has been instantiated using a builder rather than directly using the main, such as like this. Let's show it. So init base. So instead of doing something like builder dot base, which is actually not valid because um, the base is it's a private struct, and even if we had um, if we also had a new base, even that is something which we cannot have because this one is private, and we need to export it. So here what we will be using is we will be creating using the builder base builder, and this base builder will be used to create the builder. So we I create a new page, and we are using I have added the builder as true, and do the set, and then the base build, which will be used for setting the a value. Optionally set the a value, and then the setup has default a value, uh, and the then we build it so that the base as ibase is the type we have defined here, which has a setup method, a print method, get a method, and e build and assert build. So for this e and assert build, basically checks if the if the base has been built using a builder uh, base builder. Otherwise, it will panic. So this restricts doesn't restrict compile, but um, in a run it will panic. So this is good enough, and however any other method are used, such as the setup and the uh, get a or print method. So whenever the methods are used, they all run the cert build initially, so that there is a check that if this build has been uh, done using the build base build. So and how the builder looks like is it has a set A and build as I told. Now what I have is I have also initiated the the con- so I want to inherit all the fields and methods which are there in the base, and then on top of that I'm adding a field b. Similar to the base build, here what I'm doing is confirming this concrete struct with iConcrete interface, and this is the function function for um, creating a concrete object. And in this factor function, as you can see here, I have the new base. We are already assigning the new base builder as true because we are user builder. We need that again, and so this will build the object, and it'll add it to the base. And this one we provide create a this variable, and we provide this same context to the new base, the base that is embedded. We provide the concrete class, the concrete object as the context for this in the base. So I'll show you how this actually will help. um, okay, we can see that here. If when we go to the get a method, we can see that if there is some context assigned to this, then I'll be running the this get a. Otherwise it will run the it will give the b dot a. So whenever I try to get a, so if there is a if you have overridden the a here, then this will help because then this will be useful. And because in the get a, when we do, if there is because there is always a context assigned when we actually build the concrete, as you can see here. So whenever the context is assigned, it will run the contexts get a method. And in the concrete we do have a get a method here. As you can see here, we are giving c dot a. So see, if there is a c dot a, if we have a here overriding the base a field, it will give the output from that. Otherwise it will get it from the base, the embedded one. So that's how it works. Similar to the base, we also have this to accommodate if there is any other derived struct from this struct, then we assign that this to the that other struct, derived struct, and then that will be used for calling. So we do not need it right now. I'll show you how we need it later on when we derive from concrete another struct. Okay. Okay. So now we are running this new we return this concrete, and then there are some actions associated with this concrete method, concrete struct. And again we have this is built, so we check if this is currently from it, if it is, if the concrete has been is used, is created using the builder, concrete builder or not, and if the base has been created or in the by the concrete by the base builder or not. And then we provide if it is built by the builder or not, and if that is so, then we check if the assert build has been is successful or not. Otherwise we panic. So we have the extra b field assigned similar to a. We have this get b, and we provide the b value. In the if I show you the concrete builder, if we go to concrete builder, so here we have set A to assign to the A, B, and check, and then build the concrete. And we also have a default concrete, so that is also fine if whenever we need a default concrete, and we do not need set A or set B, we just want to get a default concrete. So that's where it is. Or if we have some specific defaults for the A and B, then we can use the default concrete. And similar to that, we also have a um, okay. So we have a print in the concrete, and first it will assert the build, and then uh, print out the base print. It will run the base print, and then it will get the b value. Again, we do not need it anymore because we are already checking that in here. So we just get the c dot b and then print it right away. So this will do. And from this concrete struct, we have another, and you can notice here the this field here is I concrete, but in here the this field was I base. So from this concrete struct we have derived another one, which is concrete 2. I have simply made a type alias here, and I'm embedding that concrete. It's because I am using the lowercase because so that it will not be public. It will be private, and here you can see for this one, for this I concrete 2 is being used as the data type. Here I have three fields. I could simply use C also without overriding A and B because they can become come from concrete. So that is fine. And here also similar to how we have we get the default concrete in the new concrete. We get the default concrete, and then provide that to create a concrete 2, get the this value and assign it to the new concrete, and return the this value. Now we also have a get A, get B, sorry, get C and get B, similar to how we had it in concrete. Then we have a setup. In setup we simply assign the C value here. Similar to in concrete we also had a setup where we were assigning the B value to some default value. Um, so so if we get a default concrete, that means we will have the C value as 10. Sorry, if we get a default concrete 2, we get the C value as 10, and if we get the default concrete, then we get the B value as 10 and the base value as 5. From the base, the A value will be 5. So that's how it is. And if we do not take any actions and we print out the concrete 2 builder without any actions, I'll just comment this out. So if we print out, then we should be, if without all this, okay, so we should be getting 5, 10, and 10, because in C value for the B we have 10, and for the C also we have 10. If we make it as 20 and run it again, then we have A coming from the base, B coming from the concrete, and C coming from the concrete 2. So here I need to mention concrete 2. Now this will come from concrete 2. So you can see here. So this is how multiple levels of inheritance in Go works. And the assignment to the this value is also very important because you have to check if that this value has been assigned or not, and then provide because if there is an override, right? If let's say I'm overriding this b here, then and I run it with some set b as 15, then that should properly work and give me the b as 15. So if I do not have this value here, um, if I do not assign this value, if I do not assign this value, then the 15, then the answer from the get b will not function properly, and it will not work as it should. So this is that is the reason this new concrete this context need to be provided to the embedding struct. So so this is how we create a concrete um, builder. We also have a default for concrete 2, and it's say exact same as concrete. Um, so this is how we build prototypal, simulate the prototypal inheritance similar to how we have it in JavaScript, and also do the um, embedding composition based inheritance, uh, the default, the way it is there in Golang. So yeah, that's it. Thank you.